Hi dear students, I hope you see this video with a good health. So our new chapter is chapter 12, which is about heat, page 218 to 225. We have two sections inside this chapter. The first section is about temperature and the second section is about heat, transferring of heat. So in section 1 we have some aims. The first one, we have to learn after finishing this section how temperature related to kinetic energy. We have to answer this question, and we have to know the comparison between the different temperature scales that we have it, and you have to know and learn some examples about thermal expansion after knowing the definition and the mechanism of thermal expansion that's changing with temperature. So before answering this question, if you just look at the faucet at your home, which has two labels. The first one, which is labeled as H, it stands for hot, and the second one is labeled as C, which stands for cold. Okay? So this H stands for hot water that comes out from the faucet, and this C stands for cold water that comes out from the faucet. But during opening the faucet, opening the H labeled part of the faucet, H labeled knob of the faucet, at first, is there any hot water? The answer is no. Maybe the warm water comes out from the faucet, or maybe the cool water comes out from the faucet. So, is this label is wrong? We have to answer this question. Using the hot and cold maybe produce a confusion. So scientifically, it is better to use a temperature. This term, okay? Oh, another example. For example, during the hot sunny days, you walk, then you want to go to the house, but before entering the house, you stand in the shadow of the porch. You feel the cold air. But when your brother comes out from the air-conditioned house and comes out to this porch, he says, "Oh, here is very hot." So what's the difference between these two terms? You say it's cold and he said it's hot. So by this way you learn that there's a confusion between using hot and cold according to the situations, according to the persons, according to this condition. So by this way you have to know that scientifically it's not right to using cold and hot. So instead of that you have to use a range of temperature, okay? And you learned in the previous grades that temperature is used for measuring how temperature. You learned that it's measure how something cold or hot, okay? But scientifically, temperature, this one is for you. This one's for grade 6 or grade 7, okay? Temperature is measure of average kinetic energy in an object. Okay, dear students? Temperature is measure of average of kinetic energy in an object. Kinetic energy, we got it in the previous lesson. We said that kinetic energy is energy of motion. So it means here we will talk about the movement or the motion of particles inside an object. it is solid, if it is liquid or gas, no matter the state of the object. Okay? For example, if you have a gas, with the molecules or atoms, and we know that all objects made up of atoms, molecules, or we have to say particles inside it. Okay, dear students? So what about average? So you got it in math. Look, we have two different places with two different temperature. Look at this one and this one. The movement of particles, or the average movement or the average kinetic energy inside an object, is called temperature. We have to know these particles maybe move side to side, or maybe bounce in their places, or maybe vibrate in their places. Okay? And the atoms and particles inside an object that we said they can move. Look at these two different kind of air or different places. This one just moved to this side by this way. This is the position or rate of the movement of the particles. So the less movement or slower movement, it's produced less kinetic energy. Okay, because we said kinetic energy proportionally change with the velocity or speed. Okay, so if the movement of particles inside an object is slow, or they have the less movement than the other one, so they have less kinetic energy. What about this one? The faster moving, it means more kinetic energy. If the amount of kinetic energy inside the object increase, so it means the temperature become higher. So this one has less temperature, and this one has more temperature. Okay, so we know now inside the definition we learned some, we explained some terms here. An object which is made up of atoms, molecules or particles. This is an object that's made up of atom, particle, molecules. Kinetic energy in the previous chapter, we explained the kinetic energy, it's energy of motion, and we described the type of movement inside the particles. And now we have to know each particle inside the molecule, inside the object or inside the matter has its own speed, has its own kinetic energy. So for example, the kinetic energy of this molecule is 23. This one, 20. This one, 18. This one, 22. And this one, 17. So, if we talk about the average, we have to know that average is like that. So, average is equal 23 plus 17 plus 20 plus 18 plus 22 over 1, 2, 3, 4, 5 over 5. So the average kinetic energy is equal 20. So the average kinetic energy is equal to N. By this way, it means temperature inside this object can't measure just by the kinetic energy of one particle inside it. You have to measure the average speed and the average kinetic energy of all particles inside it, and it gives you the exact temperature, which is measuring of average kinetic energy in an object. And this one is used for comparison of two different temperatures, so that they have the different kinetic energy, different speed, and with a different temperature.